Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good evening. So today I'm going to teach you how to calculate capacitance contribution. So this is especially for supercapacitor. If you are making a composite material that have a combination of pseudocapacitor and EDLC, actually you can calculate the capacitance contribution. This is using TRASATTI method. So we have two methods, done method and also TRASATTI method. So TRASATTI method is a specific way to calculate if you are dealing with pseudocapacitive material and also a combination of pseudocapacitive and EDLC. You want to see what is the contribution of pseudocapacitor and also the contribution of EDLC. Okay, this is the general formula. C power of -1 equal to constant V1 over 2, V is the scan rate, plus CT minus 1. Okay, C, before that, you must do an experiment, which is a cyclic voltammetry at different scan rate. Please study at very close scan rate, don't study at big scan rate to get accurate data. For example, you are study cyclic voltammetry at 1 millivolt per second, 2 millivolt per second until 10 millivolt per second. So minimum you should have 5 points. So C is your capacitance value. It can be either areal capacitance or it can be farad per gram. If you are measured by area, is areal capacitance. By mass also can farad per gram. So then you get the value of constant V1 over 2. Okay, this is the value of the gradient because this graph will mimic y equal to mx plus c. This is the y, mx, v power half is the x-axis, the constant is the gradient, and ct is the y-intercept, the c value. So when we learn basic mathematics, it is y equals to mx plus c. So if this is complicated, move to formula number 2. It is a simplified version of formula number 1. C power of -1 equal to 1 over c. Constant V1 over 2, we didn't change anything. Plus CT power of -1 is 1 over CT. So what you need to plot is, you plot your graph after you doing CV at different scan rate. What you need to do, you get the capacitance value and you are using Excel, you get the value of 1 over C. For example, my capacitance at 1 millivolt per second is 100 farad per gram. So 1 over C equal to 1 over 100. It's like that. So then what you need to plot is, you plot your scan rate power of half. For example, 1 power of 1 over 2. 2 millivolt per second power 1 over 2. So you can using calculator. And also, if you already have the x-axis, you already have the y-axis, and also you already have the x-axis, you can plot in the origin or Excel. Then you can get the graph. When you are using origin, you can do is, you can fitting the graph and find a linear curve. So you can, wait a minute. Okay, at origin, if you already plot this graph, you got just find the icon for fit linear graph. Then the software will calculate for you the value of gradient and also the value of the C value. So it's automatic, no need to do anything. So if I have time later in another video, I will show you how the origin will calculate all of that. So this is the basic formula. Then you can get a very good straight line graph. Okay, so focus only until this one. So let me show you the simulation. So for example, this is the graph that you get from the origin. The x-axis is your scan rate, power of 1 over 2. Make sure the scan rate in millivolt per second. And also your y-axis is either your areal capacitance or your mass capacitance. Okay, for example, gram per farad. So you will get, for example, 4 point or 5 point, you can get a straight line. Then using the origin, you can fitting the linear graph. It will fit until you get the value of C and also gradient. So it is important to do that. Okay, next, after you finish, then you must be curious how to get the value of CT. CT is the total capacitance value, meaning that the capacitance of EDLC plus the capacitance of pseudo. Okay, to get the value of CT, you already got your graph. So you already got your C and also gradient. What you need to do is see the y-intercept equal to 1 over CT if you see the formula number 2. So you can see 1 over CT equal to C and 1 over C equal to CT. So you get the value of capacitance total how much. Okay, 1 over C, you got the C value, and 1 divided by your value, you get CT, capacitance total. So what you need to do by the CT, after you already get it, you want to measure the capacitance for EDLC. Again, for the EDLC, using the same graph, cyclic voltammetry at different scan rate, okay, you insert the value of capacitance and you insert the value of, in this case, the x-axis is changing. The x-axis is scan rate power of -1 over 2. And you plot again using the origin, you get the same straight line. However, in this case, the intercept is not C. It's not CT. The intercept in this case is C EDLC, capacitance for EDLC. So now you already know the capacitance of EDLC. You also already know the capacitance total. So to get the capacitance of pseudo, C total tolak C EDLC minus C EDLC. So you can get the capacitance for pseudo. Okay, so to calculate the percentage contribution using this formula. So for capacitance contributed by EDLC, C capacitance for EDLC divided by C total times 100. For capacitance contributed by pseudo, C capacitance pseudo divided by C total times 100. So it's quite easy. However, it's quite tricky if your scan rate is large. For example, you study 50 millivolt, 100 millivolt, 200, you cannot get a very good result. Please make sure your scan rate is very close to each other. For example, 1, 2, 3, 4, 5 millivolt per second, or 1, 3, 5, 10, 15 millivolt per second. So you can do your experiment and find the contribution. And for your information, TRASATTI method cannot calculate for battery type material. It's only specific for supercapacitor. Okay, for battery type, you need to learn the done method. Later, if I have time, I will reveal how to get the done method. So hope you enjoy the video. Thank you very much.